All right, I'm going to go ahead and get started. My name is Amanda Sheffield, and I'm from the California Nevada Climate Applications Program. And today with NIDIS, we're presenting the next in a series of California Nevada Drought Early Warning System, Drought and Climate Outlook webinars. First off, I'm going to pass it off over to Alicia Mars, who's co-hosting this webinar with us from NIDIS, so she can talk a little bit about NIDIS. We have quite a few new listeners this time in our series, and we'll go ahead and pass it over to her.
Great, thanks, Amanda. I think I can't see the slides yet. Can we share those?
Oh yeah, let me see. Sorry about that.
It's okay. All right. Well, thanks everyone for joining us. I am, like as Amanda said, Alicia Mars. I'm with NIDIS, the National Integrated Drought Information System. I'm one of the regional drought coordinators we have here, and my territory is the Western U.S., so I serve as the liaison to our drought early warning systems, basically from the Rockies west. So NIDIS, if you're not familiar, is a NOAA program. We have an interagency mandate, however, from Congress to help coordinate drought and climate science to help the United States as a whole and stakeholders better understand why and how droughts affect their society, economy, and environment, and then hopefully help people better mitigate the impacts of drought. So to do this, we've been tasked with setting up a network of drought early warning systems that will ultimately fill in the map you see on your screen to create a national drought early warning system. So we have a series of regional drought early warning systems, as I mentioned, and you sit in, likely, in the California and Nevada DEWS, as we call them affectionately. And so the role of these drought early warning systems can be a little confusing. The words early and warning and system all come together to basically emphasize the importance of improving the access for stakeholders to drought and climate science, so again that they have enhanced capacity to deal with the impacts of drought and to better plan and to better mitigate and then adapt to changing climate situations. So as I mentioned again, obviously what we're trying to do is ultimately build off these regional drought early warning systems. So we're leveraging activities both within California and Nevada and regionally, but also tapping into initiatives that may be happening in DEWS in other parts of the country as well. So Mandy, you want to go next slide? So the California-Nevada DEWS, as I mentioned, is an expansion of what was the original California Drought Early Warning System, which was one of our first early warning systems. So as we fill in the map, we're building off the success of the California DEWS and building off the recommendations from Governor Sandoval's Nevada Drought Forum, which spun off his role as chairman of the Western Governors Association and WGA's Drought Forum. We expanded this region to include California and Nevada. And so what we're trying to do here with the DEWS is utilize new and existing partner networks to help folks better understand and utilize drought, climate, and science. Drought and climate science and information to make better decisions. We are in the process, literally as we speak, of developing a strategic plan for the activities that we will be doing over the next 2 years as part of this drought early warning system, and that will be made public on drought.gov. You see the web address there on your screen as well. You can also find out more information on events like this and other outlooks, whether they be in-person or webinar-based, and other research initiatives and partner activities on those pages as well. And Amanda may mention this again later, but the slides and recording of this presentation webinar will all be on drought.gov. And I would say the easiest way to find that information in the future will be to go to the calendar page on drought.gov and look for today's date, and you will be able to directly access all of those presentations and the recording. Okay.
And part of this DEWS network is working with groups that are tied into say, California and Nevada, the stakeholders, decision makers, and what's been going on in our region. And that's part of my role as one of the coordinators for the California and Nevada DEWS. I have counterparts in Nevada, and I sit in California. And we fall under the umbrella of the California Nevada Climate Applications Program, which we are a NOAA-funded program that works with climate information for decision makers in California and Nevada. And we host these outlooks with NIDIS, and we also do other programs, such as we have some upcoming two-pagers I wanted to tell you about one including La Niña, because obviously it will be discussed today, but also one hopefully in the next week or two on seasonal forecasting, which will be explaining more about what are our skills currently in forecasting, why are the skills like that, and an explanation of NOAA forecasts with examples, especially from last year's El Nino and what happened with that case. Before we get started with the webinar, I'm going to move to the agenda next. I just wanted to take a chance to acknowledge the passing of someone you may have seen at these webinars or our meetings previously. Dr. Kelly Redmond passed away earlier this November, and he was the Deputy Director for the Western Regional Climate Center, and he spent more than 3 decades doing programs like this with CNAP and the Western Regional Climate Center, and was an integral part of what we've been doing, including these webinars in the past. Okay, to move to today's webinar agenda, the first talk is going to be on the drought and climate status update in our region, and that's going to be by the U.S. Drought Monitor author Dave Simmerall, who's at the Western Regional Climate Center. And then we're going to move into thinking about some of the big impact events that we've launched off with in this water year. What's our current forecast looking like with ENSO from the National Weather Service, and then talk about the Nevada drought and impacts with the state climatologist. So with that, I'll get started and launch it over to our first talk with Dave Simmerall. And I'll pass that over. And we're going to mostly save most questions for the end of the presentation, of all the presentations. So go ahead and type your questions in the question box or the chat box, and we'll get to them then.
All right, I just want to make sure you can see my screen.
You're good.
Okay. Thanks, Amanda. This is Dave Simmerall, as you mentioned, from the Western Regional Climate Center. I'm also one of 11 authors for the U.S. Drought Monitor, and I'm going to be providing the drought and climate update, and mainly focusing on the beginning of the water year, but I'll provide some context as well, going back to the beginning of the year. So to get started, what we have here, this is the current U.S. Drought Monitor map, which just came out yesterday morning. And as you can see, we've seen improvements across the northern part of California and across Nevada. So since the beginning of January 1st, we've seen significant improvements across Nevada and northern California. The southern half of California has remained very dry over the past year and has not seen many improvements in that area. Portions of Northern California have seen some pretty significant improvements since January 1st, up to 4 categories in drought improvement. And in northwestern Nevada as well, we've seen multiple category improvements there. Overall, especially in California and parts of Nevada, we've got some longer-term hydrologic impacts that have persisted within the state. So taking a look at, these are 2 change maps based on the U.S. Drought Monitor maps. And on the left is the past 2 months. So this is basically almost from the beginning of the water year. And on the right is from the beginning of the calendar year, January 1st. So you can see on the right, since the beginning of January 1st, we've seen significant improvements, as I mentioned, in Northern California and across most of the state of Nevada. Over the past 2 months, we've seen 1 category improvements in Northern California, as well as portions of Western and East Central Nevada, as we've had several storm systems that have come through the area in October and a couple this month as well. So looking at the status overall out west compared to a year ago, you can see a lot of red on the map on the right. That was December 1st, 2015. And looking at today will be on your left. So we've seen a lot of improvement across the west. Northwest is a different region, but we've seen a lot of improvement there, as well as across northern portions of Nevada and California. Looking at the state of California over the past year, you can see we've gone from 97% of the state being in D1 to D4 drought in California. And as of the last map, I've mistake on this. November, actually should be November 29th, that 73% of the state is currently in D1 to D4. So we have seen improvement across the northern portions of the state. Compared to a year ago in Nevada, you can see significant improvement. December 1st last year, the state was in 93%, was in D1 to D4 drought, and currently we're at 34% of the state in D1 to D4. To provide a little context as to the improvements and how we got to where we are now, this is looking at climatological rankings, and this is statewide for California. And on the left, this is over the past 48-month period. California ranks the past 4 years as the warmest 48-month period on record, as well as the 8th driest. And over the last 12 months, it's been the 7th warmest and 35th wettest. So we've had some improvement over the past year, and you can see that reflected in the conditions on the map. To provide a little more context statewide in California, these are time series plots of temperature and precipitation. They begin in 1894 or 1895, the beginning of the observational record, and up to present. So on the left is mean temperature for 12-month periods, and there's a 10-year average, which is the black line. And you can see the overall trend is pretty clear, especially starting in about 2000. There's definitely been a warming trend across the state. We've had a little bit cool down a little bit this year, but the previous 2 years were very warm in California. Looking on the right, this is precipitation. Not as much as a trend, you can see. It kind of fluctuates all over the place. You can see the area that I have marked in red. That's the drought period that we were experiencing. And you can see this past year has been a little bit better. We had above average precipitation across the state. Looking at the state, the same climatological rankings for Nevada statewide. For the 48-month period, it was the second warmest on record and the 53rd driest. And over the last 12 months, 11th warmest and 30th wettest period. These are the same time series plots for the statewide in Nevada. You can see the same trend in temperature over the past 16 years. There's been a clear warming trend across the state. And just like in California, the precipitation kind of fluctuates all over the place. But you can see we've had improving conditions as far as precipitation over the past several years. Average temperature departures, this is looking at the beginning of the water year this year, October 1st. And you can see on the left-hand side, this is beginning October 1st. So the warmer colors represent greater temperature departures, and the cool colors, which there aren't many on the map, they're in green. Those represent below normal temperatures. So you can see the West in general has been above normal temperatures since October 1st. To provide a little more context out a little bit further, the three maps that you can see to the right of that, 12 months, 24 months, and 36-month periods, you can see there's a clear trend that it's been warm across the West. Looking at percentage of average precipitation starting at the beginning of the water year this year, you can see the cooler colors are above average precipitation, warmer colors are below average precipitation. So we've experienced since October 1st above normal precipitation across most of northern California and most of northern Nevada, as well as some smaller pockets down in southwestern Inyo County and San Bernardino County. In Nevada, northern and western portions, as well as southern Nye, have been above average. And over the past year, the trend has continued into the fall, where the southern half of California has remained below average, as well as central and southern Nevada. Looking at some station data, these are station indexes from California that most of you have probably seen. And on the left is the Northern Sierra Precipitation 8-station index, and on the right is the San Joaquin 5-station index. And you can see we've had a really good start in the Northern Sierra. Currently, we're right on track with the wettest year on record from 1982-83, that season. It's still early to tell where that's going to go, but it's a positive start. And a little further south in San Joaquin 5-station index, you can see we're above average in that area as well, but not doing quite as well as Northern California. Moving further south to the Southern Sierra, below normal precipitation in that area. Taking a look at the current snowpack conditions across the area, we're having above average snow water content in the Northern Sierras as well as the Trinity Mountains, and below normal in the southern half of the Sierras, as well as the Ruby, Shell Range, Starbridge Mountains of northern and eastern Nevada. Kind of taking a look at a closer look at some of those snow water content levels, the percentages of normal. On the left-hand side, we have the northern and central Sierra, and you can see kind of in the Lake Tahoe area, like Lake Tahoe Basin and north of it, we've got a lot of above average snow water content levels. Moving further south, it's been much drier and below normal levels across most of the central and southern Sierra, except for there are some scattered stations that are sitting just about normal to above normal. But again, it's really early in the season to be able to make any definitive statements on the snowpack. Looking over into Nevada, we have below normal SWE levels across most of the ranges in northern and eastern Nevada, although we have a couple stations that are reporting above normal. We can see the green up by south of Elko in the Ruby Mountains, and further south in the Diamond Mountains as well. We have above average snowpack. So something we've been seeing a lot over the past several years and is this looking at rain versus snow throughout the season. We've been seeing a lot of areas around the west that are receiving above average precipitation, but it's not in the form that we want it in. So with these warmer temperatures, as you can see on the right, I have our temperature departures from October 1st. If you look on the left-hand side, these are snow-tell stations, so these are stations that are up in the mountains, and this is starting October 1st, precipitation percentage of normal. And you can see across the west, including California and Nevada, most of those stations are above normal as far as precipitation starting in the water year. But if you look to the next map on the right, this is the snow water content percentage of normal, and you can see the trend across the west in general that you have below normal snowpacks in those areas. So what we're seeing is warmer temperatures and a lot more rain events instead of snowpack. Moving ahead, looking at some of the stream flow conditions across the region. These are 7-day averages across California. You can see most of California is flowing. The stream flows are near average to above average, and that's in relation to, we've had several storm systems that have moved through over the past week, so the stream flows are running near normal. We do have some low stream flows that are showing up in the northeastern part of California, as well as the Salinas River down by Monterey, and some of the streams coming off, rivers coming off the southern Sierra on the western side. Looking at Nevada, kind of same thing. We've got near normal stream flows across most of the state on the Humboldt River Basin and the East and West Walker River. We've got a few below normal ones on the Truckee River, although those river systems are highly regulated, so it's partially in the operations of those reservoirs. Looking at current reservoir storage. On the left-hand side, you can see California and Nevada are both below normal. California has made some improvements. The black lines that you see on these are the average for this time of year. So you can see both states are below normal. This is a current reservoir storage level for the state of California. This is just downloaded this morning. And you can see that many of the reservoirs across the state are still below normal. And part of that is not only related to precipitation, but the variability is related to reservoir operations as well. Compared to last year at this time, we've seen some overall improvement in storage levels in Northern California. You can see some of the larger reservoirs like Shasta is at 108% of normal. It also did pretty well last year too. Folsom is near normal as well. But we have some ones that are far below normal, like Lake Cachuma, which is down in the Santa Barbara area, which is only at 10% of normal right now. Looking at Nevada, they have way less reservoirs, obviously, than California, but taking a look at some of the areas there, overall we've seen improvement compared to last year. You can see these are a couple of the river basins within Nevada. The Truckee River Basin, you can see where I've highlighted in the red. Last year's percentage of average was 31%. This year we're sitting at 71%. Carson River Basin, 33% compared to 7% last year. And the Walker River Basin is looking really good this year so far at 116% of average compared to 37% of average last year. Further south in the big reservoir down in Lake Mead, it's very low and only 37% full at this point. Looking at Lake Tahoe, for those of you who aren't familiar with Lake Tahoe, once it falls below its natural rim, which is the red line on there, basically no water can flow out of the lake into the Truckee River, which feeds multiple reservoirs, including Donner, Boca, Stampede, and Prosser. And that's our water source basically for the city of Reno. Looking at current groundwater in California, we're still seeing a lot of below normal groundwater levels across the Inland Empire, San Joaquin Valley, and around Santa Barbara and north of that area as well. In Nevada, we're also seeing large concentrations of below normal levels in the vicinity of Fallon, the Carson Valley, and the Amargosa Valley. And with the recent storms we've had in October and November, we've seen some pretty good improvements in soil moisture across Northern California and Nevada, although we still have a lot of dry soils across the southern half of Nevada, as well as portions of California as well. Drought impacts we're seeing across both the states. California still remains under a state-declared drought emergency. As I mentioned earlier, Cachuma Reservoir is currently 10% of normal, and that reservoir supplies drinking water for Santa Barbara and some communities in the vicinity. Something that came out in the past several weeks, the Forest Service has been doing aerial surveys of tree mortality across California's mountains. And because of drought-stressed trees, we've had infestations, bark beetle, and we've had historic levels of tree die-off. And these figures just came out just a few weeks ago. And as of 2016, they've estimated that in relation to drought and bark beetle infestations that 102 million trees have died across California, with the greatest concentration of those in the southern and central Sierra Nevada. And the Forest Service is expecting increasing mortality in the northern part of the state, including Siskiyou, Modoc, Plumas, and Lassen counties as well. And that about wraps it up. Thank you.
All right. Thank you, Dave. As I said before, we're going to save questions and answers for the end, but thanks, Dave, for that great presentation. I'm going to now pass it over to Nina Oakley, who's going to add a few more details onto how this water year has gotten started, including some of those storms in October and November, and what they may or most likely won't mean for the rest of the year.
Right. Hi, everybody. As Dave mentioned, precipitation since the start of the water year is more than 150% of normal across much of Northern California and Northern Nevada. And it's important to note that in this case, since the start of the water year, that October has done most of the heavy lifting here. Nevada was really drier than normal. And as was California, and except for a few coastal locations in California. So we'll take a closer look at some of the storms that got us here, and we had a really couple of unique storms to start the year. Next slide, please. Next slide, please. Thanks. So I'll preface this explanation with a brief definition of atmospheric rivers. Atmospheric rivers are narrow corridors of high water vapor transport that occur in the lowest 2 kilometers of the atmosphere. And this image shows water vapor in the atmosphere measured by satellite, and the purple areas show low water vapor, and blue to yellow to red areas show areas of higher water vapor content. And so you can see in this loop, this narrow corridor of high water vapor transport traveling across the Pacific here. And so atmospheric rivers occur primarily in the cool season, October through March, and have preferred areas of occurrence worldwide, one of them being the west coast of North America. And so when an atmospheric river traveling across the Pacific encounters the steep coastal terrain of California, that moist air is forced to ascend, resulting in precipitation. And atmospheric rivers can produce abundant and sometimes intense rainfall, and are important in California both in terms of water resources and natural hazards. Atmospheric rivers are typically responsible for flooding and other natural hazards in the winter in California, and also in some cases in western Nevada. So if conditions are favorable, the moisture in an atmospheric river can spill over the Sierra Nevada into western Nevada, or on occasion, the atmospheric river moisture can actually reach northern and southern portions of Nevada by going through terrain gaps to the north and south of the Sierra Nevada. So looking at a couple of storm examples to kind of kick off the water year, we had an atmospheric river storm, 2 atmospheric rivers back-to-back that impacted California and western Nevada. And these storms began as Typhoon Songa in the western Pacific, and that typhoon retained some of its tropical juice as it traversed the Pacific, and this in combination with a low pressure system produced these 2 subsequent atmospheric river storms that impacted the West Coast. And many folks were likening this to the 1962 Columbus Day storm in the Pacific Northwest, which also began as a typhoon. And this particular storm had characteristics that were favorable for precipitation to spill over into western Nevada in the immediate vicinity at the base of the Sierra Nevada. And this doesn't happen with all atmospheric river storms, but when it does occur, it can cause heavy precipitation in western Nevada. And this mechanism for the spillover is a topic of current research. It's not all completely understood. So over 3 days with this storm, far northern California saw over 12 inches of precipitation. Sierra Nevada saw 8 or more inches, and northwestern Nevada saw 1 to 2 or more inches during this storm. Next slide, please. And then moving towards the end of November, we had another interesting case, and in this case we had an upper level low pressure system that began to interact with a very late season dying hurricane. The remnants of Hurricane Seymour were traveling northward, and the moisture from them, as you can see in this figure, there's a little kind of a little red circle off the coast of Baja California in the figure in the bottom left. That's the dying hurricane, and then kind of the green blob further north of it off the coast of California is the low pressure system, and this low pressure system was able to entrain moisture from this dying hurricane and produce some precipitation along the west coast, some of this even making it into northern Nevada. So northern California saw 3 or more inches from the storm, Sierra Nevada roughly 3 or more inches, and western Nevada some locations saw 1 inch over the 3-day period, and north central Nevada in the 1 to 2 inch range. And next slide, please. And so November was pretty devoid of big storms for California and Nevada, but we did have one weak atmospheric river event towards the latter half of the month. And we had this weak atmospheric river. It was a little stronger as it was hitting Northern California earlier in its cycle than the image I show here, but it kind of broke apart over time as it moved southward. But one thing that was notable about this storm was it finally brought some much needed precipitation to Southern California. Some locations along the south coast, south of Monterey, into Santa Barbara County, San Luis Obispo County, and through Orange County and San Diego, these coastal locations which have been very dry, some of them saw a ½ inch to 1 inch of precipitation. And this is the area where we're seeing some of the worst and most persistent drought impacts. So it was great for them to get some precipitation, but this is certainly not going to break drought impacts. Next slide, please. So we've been getting questions at the Western Regional Climate Center about what's been going on so far this year and how can we put it in context of the El Nino Southern Oscillation. So the question we're getting is, are these storms that we've had so far, especially the big October storms, are these storms La Nina? And so we do have weak La Nina conditions, cooler than normal sea surface temperatures in the eastern equatorial Pacific that are currently present, and the atmosphere has shown coupling with these sea surface temperature anomalies. And these La Nina conditions are slightly favored to persist through the winter season. However, the linkage between the atmosphere and tropical ocean really didn't start until mid to late October. So, and then the influence on the western U.S. is usually slightly lagged from what's occurring in the equatorial Pacific. So, so it's difficult to tie these October storms, which were very anomalous in their formation, with one kind of spawning out of a typhoon and the other from this anomalously late season hurricane making its way north. So it's difficult to pinpoint those on La Nina, but if you click, advance forward one. So folks are asking, are these storms La Nina? Well, with a given ENSO phase, El Nino or La Nina, it can influence the likelihood of storms affecting a particular region of the U.S. West Coast. La Nina typically favors the Pacific Northwest to receive above normal precipitation and the Southwest to be drier than normal. That's the canonical pattern. Though it's difficult to tie the occurrence of any one individual storm to ENSO phase. So while these La Nina conditions may make it more favorable for storms to take a certain path, we can't attribute any one individual storm to its occurrence to La Nina specifically. And next slide, please. So we've also been getting the question that we had a wet October in much of Northern California and Western Nevada. Does this mean anything for the rest of the season? And the short answer is no, but I do have a figure to explain this. So along the x-axis here is precipitation total for October for the climate division shown in the upper right. And then we have on the y-axis, this is the November to March precipitation total. And each dot represents the combined October and November precipitation. So if you follow the x-axis up, you get what the October total was for a particular year, and take that over to the y-axis, and that's what the November through March total was. So you can see, for example, some of the individual years of interest are marked. And so we see really no relationship among these among the October precipitation and November through March precipitation. And some folks were asking, well, we see that when we have our biggest Octobers, the 1899, 1900, and 1962, 63, those aren't the bottom of the barrel for November through March precipitation. Does that mean, you know, we'll be spared a very dry November through March? And well, it's really difficult to say given we only have 2 points out this far, so it's not a big sample size to draw from to get any predictive power. And then when we move towards a drier October, you see that we have a range from anything, when we have among our driest Octobers for this area, anything from your driest November through March to the wettest November through March among those dry Octobers. So October precipitation really doesn't give us any predictive power. And for this climate division for October 2016, it was the third wettest for this particular climate division. And next slide, please. And here, same thing for the Northwestern Nevada climate division. Again, we don't see that any significant relationship there between October precipitation and November through March precipitation. So although we'd love it to be a predictor, we don't have any predictive power for the rest of the season based on October precipitation.
Great, thank you, Nina. Going on that trend, we're going to then move over to Andrea Baer, who's going to talk about what the future forecast is looking like for ENSO and for California and Nevada, how the atmosphere will act over here.
Okay. Let me know when you can see my screen.
You can see it, you're good.
Okay, thanks. Okay, good morning, everyone. So yeah, I am going to continue on from what Nina started. This is just a little schematic, little graphic of the typical type of La Niña conditions, the most common trends that we see during La Niña. And as you can see, this we get this amplified polar jet. Oftentimes this blocking high pressure in the Gulf of Alaska, the northern eastern Pacific there. And then we get this Pacific jet stream of variable strength that often the mean position likes to move itself into the northwest portion of the U.S., the southwest portion of Canada. So as she mentioned earlier, that's where we tend to see more of the wet, cold type conditions. We also get that cold pattern that moves into the north central U.S. But what you can see for California and Nevada there, you get varying outcomes. So there really isn't a nice packaged up trend or tendency that we get in the California-Nevada area, other than sometimes that wet signal does dip down into the northern portion of California. So let's see. Moving on here. So what I'm going to talk to you a little bit about today is where we are with this La Niña and how much of an influence it's having on the climate outlooks for this coming winter. We do have La Niña conditions currently that have started. They're present at this point in time in the Pacific Ocean. And the sea surface temperatures around the equator are below average in the central and the eastern portion. I'll show you that in just a moment. But I do want to point out that La Niña is just slightly favored to persist as we move into winter. And I'll show you some graphics to support that. So as we look at the sea surface temperature departures in the tropical Pacific over the past about month, the sea surface temperatures were below average across the central and the eastern Pacific. But if you look at the change in the weekly sea surface temperature departures over the same past month, you have these small regions right here of SST anomalies that have increased across the central and central and eastern portion, but the far eastern, they've actually decreased. And looking at that, here's the latest weekly, so the past week, this Nino 3.4 region, where that's our key region for looking at whether or not, this is how we determine whether we're in La Niña, El Nino, or neutral phase. And what we're looking for here is for this number, the minimum threshold for La Niña to be 0.5. And as you can see, this has warmed a little or increased a little to 0.4, but it has been below that the last few weeks. It's important to note this is a weekly sea surface temperature departure, and really to determine, and so we look at monthlies. So while this has dipped a little, it does wobble back and forth, especially when we're in this period of very weak La Niña conditions. And this also shows that point as well. This is looking in the central and eastern Pacific, the upper ocean, the weekly average temperature anomalies. And as you can see, since early November here, we've really started to weaken those negative anomalies. So whether or not it stays there is yet to be seen, but the trend is looking like those are weakening. These are the forecast output that our Climate Prediction Center puts out with the International Research Institute. This is the model output in early November. So you could see the models were a little more confident of this La Niña developing and persisting through the December, January, February season, and then after that tapering off and moving more into neutral category. But the mid-November models backing off a little more and looking like La Niña is only slightly favored to persist through the winter, but it's looking like it may just persist through the early part of this winter and then wane after that. Here's another way of looking at that. These are all of the dynamical and statistical models that are looked at to determine ENSO status. And looking at the average, this bold yellow line here, it really does look like these the weak La Niña conditions are really just going to persist through the early part, this December, January, February timeframe, and then again taper off after that. So you may be wondering, how do we determine whether we're moving into a La Niña or an El Nino? What I want you to look at down here is this July, August, September season and August, September, October season. We have these oceanic Nino index values for that season, this first season, to be this negative 0.6 and then negative 0.7. And again, that threshold is negative 0.5 to move into La Niña. And this number right here is being calculated right now, but it does look like it is also going to be below that threshold of negative 0.5. So basically what that means is these three seasons, we are in a La Niña, a weak La Niña. We have entered that phase. But in order for it to really be classified as an event, a true event, we need to keep that negative 0.5 through this November, December, January season. So that remains to be seen, whether or not that can happen. It has enough gusto, I guess, to keep going. I don't have these same graphics for Nevada, so I apologize, but these are some graphics that our Sacramento Weather Forecast Office put together for their partners and customers. And it just takes a look back at past neutral events where we have neither La Niña or El Nino conditions, and then also during weak La Niña conditions. So on the left-hand side of the screen, what this is telling you is that past neutral years have really yielded more dry winter seasons than we do get wet ones or normal ones. Again, this doesn't determine a future outcome or a forecast. This just gives us a range of possibilities of what's happened in the, from past events. And then when we look at weak La Niña conditions, you also see that dry years have occurred more often. Interesting that in central and southern California really haven't had many wet years. So, so that's probably what we're, you know, more of a tendency of what we're going to look at, what we're going to be seeing in the southern part of the state of California. Okay, if we look at snow anomalies for December, January, and February, and the frequency of occurrence, if you look on the right-hand side here in the California, Nevada area, out of all of the La Niña years we've had since 1950, the snow anomalies were above average about 60 to 70% of the time in this northern California area, less so in northern Nevada, but then kind of a mixed bag, or really not giving us any sort of signal in the central and southern portions of both states. Moving on to the official forecast that have come out of our Climate Prediction Center, I've put the next 3 seasons up there. So the season is right here, December, January, and February. This is our first season. And really, we're just favoring a slight tilt in the odds for below average precipitation in southern Nevada and the southern half of California. And then moving on through the winter as we go, again, just slight favoring in the southern portion of California and Nevada, and again in February, March, April. These outlooks are put together with combined tools that combine long-term trends, soil moisture, and El Nino or La Niña composites when it's appropriate. So they have given a little respect to La Niña based on the fact that we are that we've entered that phase, but not a whole lot of respect. The rest of this is coming from our other tools. And in this area, these areas right here where you don't see either an above normal or below normal signal for precipitation, we really don't have a favored category. Basically, there isn't a forecast for that area because there's nothing in our forecast tools that's really giving our forecasters confidence to favor one category over the other. So there's a lot of uncertainty in those areas, and pretty much anything's up in the air to be a possibility for the forecast. Looking at the seasonal temperature outlooks, so starting in December, January, and February, slight tilts in the odds towards above normal temperatures in the northern portion of the state, and then getting a little more confidence, a little more of a tilt in the odds as you move further south. Also a similar story in Nevada. But then as we move through the winter, not having a whole lot of confidence, again, to make a definitive forecast in the northern portion of California, and the slight northwest of Nevada there as we move into January, February, March. And then a similar story in February, March, April. So those are our official outlooks that just came out in mid-November. They'll be updated the 3rd Thursday of this month, so you'll get all of the newest forecasts then off of the Climate Prediction Center webpage. And then the last graphic I want to show you is our seasonal drought outlook. And this is valid from now until February 28th. These come out monthly, and they're available for the monthly drought outlook or the seasonal. I chose to show you the seasonal. So as you can see, for much of the southern part of California and this portion of Nevada on the western side, really we do expect drought to persist. And then a little bit of improvement, but some remaining in the northern half. And that's based on the forecast that there could be, with that La Niña, there could be some additional, some higher than average precip in that northern part of the state. So basically, again, La Niña is here. It's very weak. It teeters. It's been teetering back and forth since late summer between neutral and weak La Niña. But we'll see if that persists. La Niña is only slightly favored, so again, right in the borderline. And then I do want to call your attention to the fact that next Thursday, the National Weather Service's Climate Prediction Center will put out their latest ENSO diagnostics discussion, and that will go over the whole status and what they think is going to happen with this La Niña. So I recommend that you see this website below next Thursday. That'll be coming out. And with that, a lot of uncertainty, I realize, but that's really all we can say at this point in time. And I will turn it back over to Amanda for Doug.
All right, thank you, Andrea, for that great summary on La Niña and the forecast. As she said, I'm now going to pass it over to Doug Boyle, who's the Nevada State climatologist. In our last webinar, we were fortunate to have Mike Anderson, who was the California State climatologist, so we're happy to have Doug this time.
Great, thank you. So it looks like we're running late, and I probably have 10 to 15 minutes of stuff to cover. Do you want me to do it next time, or do you want me to go ahead?
Go ahead this time. We haven't gotten too many questions in the question box, so go ahead and finish off the hour at least.
Okay. So this is a picture actually of Mount Lincoln. It's very close to where I'm working all day today. Wow, this is not trying to get. So I'm in the field. So apologize for the noise and distractions. I thought I'd start with USDA drought disaster map, and the reason I'm doing this is because this is really kind of the closest link to most of the resources that I'm aware of for at least the agricultural sectors in Nevada that are impacted by drought. And this map was put out November 30th, and essentially all the counties in Nevada that are red have been declared a drought disaster area, and these other orange colors for these two other counties, those are counties that are also declared, but through a contiguous county procedure. So they're adjacent to drought disaster counties, so they are also available to, benefits are available to people in those counties as well. The reason I'm showing this is because this map, which is linked to, I've got a few examples of some of the larger FSA programs. For example, the Livestock Forage and Disaster Program, approximately $10 billion from April 1st, 2014 to present, has been distributed based on the conditions that change the different counties from white to red. There's a bunch of other policies as well, but this is really important, and primarily because the drought disaster declaration is made automatically based on the conditions in the U.S. Drought Monitor map. Any area in any county that's in a D2 condition continuously for 8 weeks during the growing season is automatically declared a drought disaster area. In addition, any county that has any amount of D3 or D4 during the growing season is declared a drought disaster area. And these declarations are made for the entire calendar year. So once your county's been declared, you're a disaster area for the entire year. Sometime in January, the entire map is wiped clean. So there's one day you're in a drought disaster area, the next day everything's fine, which seems really odd for drought conditions. But then say if you have any D3 in your county for that week's drought monitor, you're automatically redeclared. And this often presents a lot of confusion to the media, particularly in the middle or beginning of January. One example, right now, this is the current drought, U.S. Drought Monitor map for Nevada. You can see just a little bit of red here on Mineral, Esmeralda, Mineral, and a little bit in Lyon County. That red is D3, extreme drought. And if that remains, after the USDA has taken their map and cleared it of all drought disaster, those 3 counties will automatically be declared a drought disaster counties. And I think there are approximately 6 counties that are adjacent to those 3. Those will automatically be declared as well. So I'm not really sure if this D3 is just kind of the width of somebody's drawing and is really represented in those counties, or if it's realistic. But it's important that that's directly related to policy, and it's going to impact people's lives in terms of the drought resources that are available to them. I just wanted to present a few. I've kind of been on a bandwagon presenting these, but issues that I have with the drought monitor, at least in Nevada. What does the drought intensity actually represent? Is it the worst condition in the area, or is the average the worst impact, or the average impact, or the average of a bunch of impacts? Is it a short-term or a long-term impact? We have these discussions with drought monitor authors all the time, and it seems to vary from author to author. The issue of a hydrologic drought versus a vegetative drought is still a really big deal in Nevada. So really, just this consistency among the drought monitor authors is something that we identified in the drought forum in Nevada as a really big deal, something that needs to be addressed. And the example that we've harped on over and over again is hydrologic drought versus a vegetative drought along the lower Humboldt River near Lovelock, Nevada, where farmers didn't get any water for over 2 years, and it was really tough to convince several of the drought monitor authors that there were any significant a D3 or D4 condition in that area, because during the summer that we saw a lot of summer moisture that we don't normally see, and the rangeland didn't look so bad, but the farmers hadn't seen water delivered in over 2 years. So it's a big deal, and if you think about how it relates to policy and resources that are available to people, I think it's really important that we figure out a way to deal with this. Just a few of the questions that I get all the time as a state climatologist in Nevada. How much precipitation is needed to end the drought? That's always a fun question to deal with. When will that happen? When will we actually get that precipitation? I presented these 2 questions, it was either 2 or 3 years ago at the AMS conference in Phoenix. NOAA had a special workshop, and they actually asked, what could we help you with? Well, these are the 2 questions that I think are at the top of my list. And what about recharging the groundwater storage? Whenever we do have these extreme drought conditions, the first thing the irrigators try to do is pump as much groundwater as they can to supplement what they did not get. The groundwater takes a big hit. How does that, if at all, get into the drought monitor, which again impacts policy? And then based on some conversations I've had with Mike Dettinger, I think if there's any way to split out the role of temperature in the drought, specifically increasing temperatures, it's just really important, and it's hard to quantify, but it's definitely an important feedback. And so those are the kinds of things that I think are really important, particularly in Nevada, that we address in the future. I'm just going to show these. These are the I usually look at these 2-class 3-month precipitation and temperature forecasts, and Andrea already basically presented these, but these are the best information I feel like I have access to convey to people what the precip and temperature might be in the next 3 months. So I use these a lot, and I definitely use the Seasonal Drought Outlook product, which I know is based on those other maps and some additional information. But that's about all I have at the moment.
All right, thank you, Doug. At that time, I don't see any questions right now, but I'll give everyone a minute to see if anyone has any questions. Thank you again to all our speakers today. It was a great session. I think we were really timely on some of the things we were talking about.
And this is Alicia Mars. I just wanted to, Doug, I'm glad you brought up some of the recommendations from the drought panel and the use of the drought monitor tool. I know that it's a great visual aid and kind of a simplification or generalization of a lot of the information that's available that sometimes is used to make decisions that may not be appropriate. I'm not speaking directly to the USDA disaster declarations by any means, but that's definitely something that we are planning to investigate and do some outreach and trainings on as part of the activities for the Nevada portion of the California-Nevada Drought Early Warning System. So you set us up quite nicely there. So, and I don't know if Dave is still on the line, if he wanted to address or provide any insight on that, some of the ways that the USDM, the U.S. Drought Monitor, is compiled from the perspective of a Drought Monitor author. If you're there.
Yeah, I'm here. That might be a topic for another conversation, because that might take a while to get into some of that discussion in detail. But I do think, I'll just say one comment too. We do look at a wide variety of indicators each week. We look at over 100 different indicators. We are communicating with people from different sectors within the agricultural sector, but those stakeholders often across the state of Nevada and California, it's often difficult to get input from those individuals, and we're looking to improve those relationships to get better impacts information. So, but I appreciate the comments, and perhaps we can expand upon this conversation in another webinar.
Absolutely.
All right, I don't see any questions here. I'll just remind everyone, as we mentioned earlier, these slides will be up on drought.gov later, and we're also going to be putting together a summary of what was heard today, so hopefully get some more details for you all that are listening and people that were not listening. And this is part of a webinar series we're doing for California and Nevada. We had our first webinar in August, and this was the second, and the next one will be in late January, trying to keep you guys up to date throughout the calendar year and the water year at important times. If you would like to get involved with the Drought Early Warning System or have any thoughts or ideas, feel free to contact myself or Alicia, but otherwise I think our websites are here, so you can check out more information about us, and I think that's all I've got. So thank you for listening, and thank you to our speakers again.